I hope you have your calculators ready. Here we go. So this is 4.4, continuation. This is the last little bit of it, using your calculators wisely. So you got your TI Inspires ready? All right, let's do this. In exercise 85 to 96, use a calculator to approximate two values of theta, which are two values also, it says. Why? Because as we talked about in class, every value, remember your little butterflies or your bow ties of your reference angles, every value repeats twice, right? Of the same. So if we're talking about sine here, it's a positive value here and here. Negative value here and here. So two places. Sine, it's positive here and here. Negative here and here. So it occurs twice always, okay? Anywhere from 0 to 360, that means I don't want any negative values and I don't want any, coterminal angles. We want two angles that make this true that are within this constraint that satisfy the equation. Round your answers to two decimal places. So I know we're so excited to use our calculators, punch the sucker in. So let's do that, okay? Secant theta. But before we start punching things into the calculator excitedly, here's what we're going to do. We're going to see, which two quadrants is secant theta a negative value? Secant theta a negative value. But you know, a secant theta, I want you guys to also think about it. Don't be weird and think in terms of secant. Think in terms of cosine. Where is cosine negative? Cosine is negative here and here because it's going to the left, okay? So we're looking for some values that are in quadrant 2 and quadrant 3. So know the kind of values that you should expect, okay? All right, that's the first thing you got to do. Number 2, let's use our calculator, but let's set it. You got to show me this work when you're working in class, okay? When you're working for any kind of problems like this. So you're going to do secant inverse, right? Negative 0.12241. And what does that equal in terms of angle? You're looking for the angle, you're given the ratio. You're given, see, you take the sine, cosine, tangent, anytime of an angle, and you find the ratio. So let's do that in our calculators. You got your calculators ready? So let's open it up. Make sure that you are in the right fixed 3. Let's check. Okay, make sure you check fixed 3 settings, right? Document settings, fixed 3 degree. Should you be in degree? Is this a degree? Do we want degree? We want degree. So make sure you're in degree mode. Okay, we want degree. And let's just set it, make sure you're in approximate there, not in a exact, okay? All right, so everything's good for me. So I'm gonna make that default. Okay, we're ready to start. So I'm gonna go to trig, right? I'm gonna go to trig. You guys are so lucky you got these fancy calculators. Secant inverse, and you're going to go to negative 1.2241 as it's stated. Enter. Oh, it gave me something. It gave me theta is equal to 144.778 degrees. Does that make sense for your quadrant 2? Does that make sense? Well, it's below 180 and it's 144. So we got the quadrant 2 value. Yay, okay? All right. Now we have to look for the quadrant 3 value, because remember, you're looking for two solutions that make this true. If I plug this value into here, it's going to give me this. Let's checky. So you guys watch. I'm going to go to seek, which is secant, right? Secant of this value here. You notice I scrolled back up. I could scroll back up to any of these values that I want to retrieve, but I want this angle here. And you know this angle? You see that? It's not just 144.778. Can you guys see this really clearly? Yes. It's not just 144.778, the end. It's actually 144 point, all these values at the end. So you have to get the exact value. Let's press enter and let's see what it gives you. Oh, negative 1.224. Perfect. Okay, so we're in good shape. Now, how am I going to get the third quadrant value though? I know the third quadrant, that means I went this much and I went a little bit more. How much more? Well, that's the same amount that you went here, right? It's the same equivalent amount of angle here and angle here. And what are those angles called? I heard you, the reference angles. So you need to calculate the reference angle. So before you do anything else, what is the reference angle? So you remember the reference angle we always denote with theta prime. Okay, theta prime. Theta prime. All right, that's the third thing you should do. Because it's 180, right? I'm sorry, you can't see that, huh? It's 180 plus the reference angle amount. So how do we do that? Okay, well, isn't it really 180 degrees? Let's look here. Isn't it really 180 degrees minus this part here? Because that's how we get to this angle here. Okay, that's our reference angle right there. So we're going to do 188. Let's turn back our calculator on. So we're going to do 180 degrees minus which one? We're going to get the 144, this guy right here. What's that going to give us? A small little, cute, and a positive value, right? Which is our reference angle. So we have to write that our reference angle is approximately 35.222 degrees. But not exactly. It's actually a long value. Okay, that's our reference angle. Now that's the fourth step now. Let's go to our fourth step. Now our fourth step is, well, I need to get to this angle right here, right? I'm going to go travel like from here all the way here. But you guys know what that is. It's 180 degrees plus this little piece, which is 35.222 degrees. So our fourth thing is going to be 180 degrees, right? Plus our reference angle, which is what? Okay, so let's do that. But we don't just put in 35.222. No, no, no. We're going to go take our calculators, and we're going to do this. Let's actually just press enter there. 180 degrees plus, I'm going to scroll back up to my 35.222 and so forth, my reference angle, and I get 215.222. Okay, so I'm going to put here 215.222 degrees, and that's my quadrant 3 answer. Do these answers make sense? In quadrant 2, 144, which is less than 180 degrees. In quadrant 3, it's greater than 180 degrees. It's 215.222, so those two answers make sense. All right, let's do another example, okay?